that you define between it. Basically, if you define a new transition that doesn't exist in either system, then you no longer have Bitcoin when you burn, say, the original Bitcoin. You now have Bitcoin Prime, which is part of the consensus metagame. Which, like, from an information standpoint, there's no problem. Like, all the information is preserved. But the fact that it's no longer on the same network that's created with all the same value, you no longer have, $10,000 Bitcoin. You now have whatever other amount.
Yeah, that's a really good point. So, because you're saying, like, if you do one of those new transitions that wasn't valid in, like, the original Bitcoin, then, like, that's fine. Everyone who's interested in your consensus metagame agrees with you, but all the Bitcoin miners who are still playing their more basic, just plain Bitcoin game aren't gonna value that transition in the same way.
Yeah, I think what even you were approaching on last time maybe is that you can't necessarily, like, have a metagame that people don't know about and have it be part of this network. It really has to be something that's agreed upon. Like, if the Bitcoin network and the Litecoin network decide that they want to create a metagame for atomic swaps, then it could be accepted, I think. Yeah.
Yeah, right. So this is feeling relevant. So, like, Tomislav and I talked about Bitcoin and Bitcoin Cash a little bit at one point, and we came to this, like, point where we realized that, like, it so far it seems like there's this big distinction. Like, there's, on one hand, there's like a chain fork, like the Bitcoin Cash fork, where the same chain splits, and then, like, a kind of different thing that only has some similarities is like an airdrop, where you make a new blockchain and, like, seed the token balances on the new one by copying balances from some old blockchain. And I was starting to get the feeling that, like, those actually weren't such different things, that they're actually almost like the same kind of thing. So I guess, like, if we do what you're describing, where we, like, make this new consensus game that merges Bitcoin and Litecoin, and, like, presumably, if it's just us, like, all the other Bitcoin miners don't care about it and all the other Litecoin miners don't care about it, then it's almost like, so, I guess, like, let's say, Jay, you and I decide we're going to do some of these atomic swaps. I'll give you some Bitcoin, you give me some Litecoin, and we do it, and our little consensus group comes to consensus over it. But then, yeah, like, that Bitcoin I gave you, you're not going to be able to take that back to, like, the regular Bitcoin chain, and, then
Yeah.
if it's but
Yeah,
it's
exactly.
almost like, I guess the other aspect of that is, then, according to the Bitcoin miners, I still have that original Bitcoin. So it's,
Well, that depends on how you define the rules, I guess.
oh yeah,
Um,
oh yeah,
yeah, if in the metagame you say that, in order to make the atomic swap, you have to burn the Bitcoin, because otherwise you're kind of just creating new money, which is totally up to the metagame how you want to do it. But I would probably, define it to where you have to burn it.
yeah. So how can we convince? I'm curious what that would look like, though, because if you say you have to burn it, like, in some way that means the original Bitcoin is burnt, that means you have to, like, verify, you have to prove that it's burnt. Well, I guess what I mean is, like, you need to get consensus over the people who are still playing regular old Bitcoin that token is burnt. Then, like, you'd have to submit a regular Bitcoin transaction too.
To the metagame, you'd have to convince them that it's burned. I mean,
Well, I guess,
or,
yeah, I guess I'm asking, like, in what sense would it be burnt? Because, like, if we've got our metagame that merges them, and the rules are, like, you can do these atomic swap transitions, and, like, so, like, let's say we do that in whatever consensus game we're playing, whether it's, like, proof of work or whatever, we reach, where, I guess, let's say it's proof of stake and we reach finality, like, that atomic swap went through, then, like, that's all basically within our consensus game, and anything, so like, anything that we come to consensus over as our little new metagame isn't really going to have any effect on the outside world, in the same way that, like, when I do some regular fork, well, actually Bitcoin Cash is a good example, like, in the same way that when Bitcoin Cash forked and people started transferring their BCH tokens, it didn't affect the, the like twin BTC tokens.
Yeah. Yeah,
Yeah.
I guess what I'm imagining here is that people that are wanting to do the atomic swap are aware of the metagame.
Yeah. Yeah. Oh yeah, totally. Totally. Yeah.
Yeah. Yeah, because otherwise you're right, there would be like no effect from one to the other.
Yeah. Yeah. Yeah, so I guess almost maybe like every new metagame is almost like a fork. Oh, that's kind of interesting. What if we think of the new game as being like a fork of Bitcoin and a fork of, like, it's like Bitcoin Prime and Litecoin Prime, and the other ones can still exist if anyone cares about them, which, is likely.
Yeah. Yeah. It'd just be really interesting. I mean, we're definitely approaching on a fundamental problem here of if we wanted to merge Bitcoin and Litecoin, or not merge them, but create an interaction system between them, then you have to get everybody on those networks to agree.
Yeah.
Otherwise, there's really no way to introduce something into the system like that.
That's right. Because if everybody on both sides agrees, then we can call it, this nice clean like merge and an upgrade of both chains or whatever. And like these really are the same Bitcoins or whatever. But if not, if people want to keep playing the old games, then it's instead like a fork or an airdrop or something like that.
Mm.
Yeah.
Yeah. Because from outside the system, they would look invalid. So
Yeah.
you'd have to change the rules somewhat.
Yeah, that is a really interesting observation.
But there is also nothing stopping you to make multiple merges, right? Different merges.
Yeah, you mean like make a Bitcoin Litecoin hybrid and also like a Bitcoin Monero hybrid with the same exact Bitcoins?
Yeah. And did you listen Greg's talk? I think on Casper. He was talking about how to connect two networks and exchange something, and he was saying that now how this is done currently is there is a contract on Archain side and there is a contract on Ethereum side, and he was saying that this can be done differently without two contracts. I'm not sure how to do this without contract on another network, because in a sense this means that what you are saying, you must trust this other network, or
yeah.
I'm not sure how this is connected.
You're talking about like for converting the current ROC token into revs or something more general than that?
I'm not sure what he was talking about.
I mean, there's I forget what they call it, like hash time locked, the thing that people have used to create atomic swaps. I'm pretty sure it's between Bitcoin and Litecoin. It's like some cryptography magic where you can prove that you can give somebody a hash that's not actually your signature yet, but once they give you theirs, then you can like combine them almost like I'm not exactly sure how it works. Have you guys heard of this?
Yeah, I've heard of it, but I don't remember the details. But something like, if we're going to do this swap, I don't want to give you the transaction that gives you the Bitcoin before you give me the one that gives me the Litecoin, because you might run off with my money. So like, I'll give you something that's useless on its own, but when combined with your thing, then it becomes powerful, and like somehow necessarily you also publish your thing so I can observe it.
Yeah, so if that really works like we're thinking, then you don't need like a runtime consensus on the network. You could just have a contract on each network where both takes whatever time lock that is and uses it to fulfill the order.
Yeah.
But that's the only way I can imagine doing it, with just contracts. Otherwise, you'd probably need a runtime logic to accept new transactions that would be considered invalid.
Yeah.
How do you mean runtime logic on only on one side, or?
I mean, it had to be on. Um, yeah, I mean, it depends on the transaction, but if you're trading Litecoin for Bitcoin, then it would have to be on both sides because one side has to.
I
Well,
mean,
yeah,
can you say I'm targeting all this one others on this another network, and when something happen, and I will know when it's finalized, and then I will do something else. And in this situation, you only need to trust this node that you are getting information
getting the information about
this finalized thing.
Finalized. Well, I mean, so yeah, it depends on how you're doing the transaction. If you're doing it kind of in this consensus metagame way, then you're creating Bitcoin and Litecoin out of thin air, basically, right? Like you're taking it from the Litecoin network and you're converting it into Bitcoin, and nobody has those Bitcoins currently, so that would be considered an invalid transaction because you'd be making them out of.
Are you acting like a normal client for the Bitcoin and Litecoin?
Yeah, I mean I think that's the idea that we had with the metagames, that you could act like a normal client and allow these what would otherwise be invalid transactions, except we can show that there's a metagame for it if the network agrees.
But there is, I mean, you can store the whole program that doing this swapping and checking, and you can store it on your own metagame blockchain, right? To be sure that everything is running as expected. But I don't see a situation in which you don't cross this boundary of trust. You are running something outside your blockchain, but this is also outside of these other networks. And
yeah.
I was thinking that in this crossing this boundary, this should be some kind of consensus on this part. So you can say, I know what is Ethereum, but I must have consensus about all these validators on Ethereum that I trust, because I don't want to trust on my own machine. So in that sense, you need another consensus about just collecting the information.
Yeah, that's interesting.
But this is okay. This is like another, and on top of this consensus, you can create another consensus, right? Because you have this
recursive.
yeah. I think that we have nested consensuses,
Yeah.
Yeah, I'm trying to tell if the recursion is like totally necessary, or if it's like each time you're getting a little bit more toward like an asymptotically perfect trust system.
Yeah, I was thinking, like some kind of function that you can calculate. Is it goes outside the boundary, or is it like a closed inside? This is like a valid consensus or valid nested consensuses, and you can detect if something is invalid. It will never converge.
So I just had this kind of like possibly interesting thought about atomic swaps. It's an analogy, and I'm thinking of it as like when you're trying to do an atomic swap where, Bitcoin for Litecoin or whatever it is, it's almost like you're playing these two separate games. Like maybe I'm playing poker on the one hand and chess over here on the other hand. And I'm trying to do this thing where I'm saying like, well, I think I want to fold this hand, but I only want to fold it if also I can like move my knight to this particular square. And the game, the difficulty is you're trying to get your poker friends who don't care anything about your chess game and your chess opponent who doesn't care anything about your poker game to like both agree that these things are going to happen together, and like their side will only go through if the other side goes through. And they're saying like, dude, I don't care where your night goes. All we're doing is playing poker, and you're like trying to coordinate that somehow.
But you are right. You are in the control of your cards on one side and on your figures on the other side, right?
Yeah. Yeah, but
So
but you can imagine, like, I don't want, oh, yeah, oh, you're right. Maybe a better example is I only want to fold this hand if my opponent makes a particular chess move.
yeah, and then you can have your contract on your meta game, which says, I will read this poker game network and this chess game network, and you becoming some kind of trust between them, right? You can
Yeah,
somehow
you're
see,
the bigger brother.
yeah.
It's
But for me, this is completely okay. You know, this is like side effects that you are introducing to one network or the other.
Yeah.
Yeah, that's interesting because, you know, there's still the person playing chess and there's still a person playing poker, but there's somebody that's coordinating, I guess, and like overviewing each move and sometimes giving instructions. Like they don't decide like the direction of the game, but they decide they're almost like an event system and kind of coordination.
And the next step would be that you are not only just a client, right, on both networks, but you are also part of the validators. Right? In that situation, you can, with your meta game, with your contract, you can say something more. You know, you can say if this in this game, if this move happens, I will validate something like this.
Yeah. So wait, can you say that part again?
I'm thinking how to create. So you're validating one network, but you're using information from other network.
Yeah.
Because you can be validator from both networks, but
Yeah.
you can also be just a client for one network and validating another network.
Yeah. So yeah, oh yeah, okay. So you're saying like you can just as part of your own strategy as a validator, you can use this external source of information, which may be another similar blockchain-y kind of game to like affect your behavior in the game where you are a validator.
Yeah, and or to get more security on this other network, because you are saying you must confirm your transaction on one network and also on this other network, so
yeah,
you're completely secure.
Or even to accept more transactions.
Yeah, or to speed up.
The other part I was thinking about is just the UTXO model, and I was I mean, so this is kind of self-evident, but I was thinking about how like all you need to reach consent. I was thinking about like how you can have consensus on the UTXO pool.
yeah,
And I realized that you don't actually have to have consensus on the pool, or you get it for free by having consensus on all the COM events. Because there's two ways that like new processes can be spawned, from a COM event and from a user. So if you can reach consensus on COM events, then you always know the new processes that come from those. And then you also have to gossip and reach consensus on user events, just like a Bitcoin transaction is gossiped.
yeah, totally. Oh yeah, that's right. So, oh right, okay. So if you come,
can you explain?
that's just like in Bitcoin. Yeah, you come to consensus on all the transfers that have happened, and then implicitly you now know. Well, okay, yeah. So if you agree on the starting state and then all the transfers that have happened, then you know the current UTXO set.
Yeah.
Yeah.
Which is good. It means it's not something you have to keep gossiping. It's just like implicit, a lot less bandwidth.
Right. Yeah.
What is the pool in UTXO?
Like the set of the UTXO set, like the token.
Oh, the complete set.
Yeah.
Okay.
Yeah, that's right. Yeah, you know, so I was also thinking about this concept of Genesis block recently, and I don't think I don't know if this is something that like most people talk about or just a little misunderstanding that I had in my own head and no one else has. But I think people usually think of like the Bitcoin Genesis block, or in general the Genesis block, as being like referring to the starting state of the system. And I kind of don't think that's a very good way to think of it for the reasons you were just saying, Jay. It's not the blocks themselves that make the state. And so it's not the first block that specifies the initial state. It's the blocks record like the deltas, you know, like the transitions of the state. So I almost think like, you know, it's not so important that we all come to a consensus on what the Genesis block is, you know, whether if we just assume our cryptocurrency started with some balances, and it doesn't really matter if the Genesis block is like me paying Tomislav or Gary paying Jay, because those two transactions would commute. Like the important Genesis or initial state is something else separate from the Genesis block. And the first block is just like the first transition.
Interesting. I guess the reason that people reach or reach for a Genesis block or that idea is that that's the only like unit that people reach consensus on in the blockchain.
Yeah.
And you have to have consensus on the state, right?
Yeah. Yeah, like there has to be some pre-existing consensus on the state to even be like playing the same game, kind of, to start, I guess, right? Because like I guess I'm thinking. Oh yeah, go ahead.
I was just gonna say I'm trying to think about how they do it in Hashgraph, because they only pass random gossip events. It's not like you get the entire history, but I think they do have some concept where you tell your neighbor what you haven't seen and they'll pass it to you. Yeah. But there might be something there as far as literally just joining and listening to enough gossip until you reach that 2/3 have seen 2/3 point, and you can tell that just from your own relative perspective, you see some kind of finality, and then you slowly like build up that state over time, but still it might be partial. So I don't know. Yeah.
So actually Hashgraph, I'm glad you brought that up, because with Hashgraph, there isn't a single Genesis block, right? There's like each validator has their own Genesis event, or are they called blocks still? Or node maybe? Or
events.
Yeah, event, yeah.
No, that's right.
But you must have some kind of connection that you are on the same network, right? I mean, you can find out that that network you are connected is does have some finalized block, and you have it, but how can you be sure that this is the network that you are looking for? Maybe someone started a bunch of bots and created the whole network.
Well, yeah. So Tomislav, let me ask that question not at a technical level, but at a social level. Like, how are you ever sure which network you want to be part of if there's like two existing, I don't know, whatever it is, similar looking Hashgraph networks with different histories, but the same rules and stuff?
Yeah, you must have some kind of identification.
It's got
some public keys somehow.
Yeah.
Sorry?
Yeah, so
couldn't you decide by a chain?
By
Jay, you said chain length, right?
A chain ID, like you were talking about in the paper.
Yeah.
Yeah. I was thinking something like that. Yeah. I was reading about this zksnark proof. In this situation, you can find out, right? You have a proof. You have some finalized block, and you can get the proof. But again, you must have something that you are comparing, right?
Yeah, I don't know, man. zksnarks still just blow my mind. I've tried to understand them.
Because I was thinking that for zksnark, if we can have this kind of proof inside the unforgeable name, then you can just see the unforgeable name, and you can say, okay, this is from this is valid. This is valid transition system. All the reductions are valid, right? Because I have this proof.
Yeah. So how does that help you with the question of what chain you're on, or which network you want to be part of, or which consensus you want to believe in?
Oh, for that perspective, I'm thinking that if you have this kind of proof, and you have, I'm not sure what do you need to provide to get this proof.
Yeah.
Josh, you said you use zero interaction proof, right? So what does it mean?
Yeah. Oh, yeah. So the N in snark is non-interactive. Is that what you mean?
Yeah.
Yeah. So, well, okay. So I also am definitely not an expert in this, but like I can say a little bit that I know. So like some of the earlier constructions of zero knowledge proofs were like interactive game, like challenge response protocols, basically. Like, so if I'm trying to prove to you that I know something, like, like for example, a valid blockchain that's however long, then you can query me and I'll give you a response. And if I answer, like if my response checks out, then you're now like a little bit more sure that I know the thing. And then you ask me another challenge and I respond again. And we basically keep going and going until you're sufficiently convinced that I know the thing I claim to know, and then we're done.
I see.
And then the snark construction just eliminates that interactive step so that I can publish some information and you can verify it and be however certain that you want it to be.
I see.
Yeah.
And in this protocol, you somehow introduce, for each reduction, you add some kind of information, right? So you can track the computation. But I'm not sure if this is possible for something like a Roland, because I was reading that Ethereum cannot be implemented with zksnarks.
So what? Yeah. So wait, what's exactly the thing you're wondering if a zksnark can solve again?
Well, they say that they can encode any computation, right?
Oh yeah.
But for Ethereum, it's not practically possible. I mean, it's possible, but it's too expensive to include this in each block, and so.
Yeah. I definitely don't know anything about the like cost trade-off profiles or anything like that. Yeah.
Yeah, that's what I was seeing at a talk. Somebody said they were doing the roll-up algorithm on the Ethereum network, and it cost them like something like $3,000 on AWS credits, like just rolling up some big set of transactions. I mean, it's definitely not something that you could practically do as like any validator on the network.
Yeah.
So Thomas, were you thinking that it wouldn't be possible to do zksnarks on Rolang, or it would be possible?
Well, first I was thinking that, Greg was saying that he now is looking at a solution to be like more performant in finding out if another shard is valid shard or not. And he was talking about continuous execution. You can introduce in Archer network. You can say, okay, I have another shard, and how do you know is this shard is valid? If all of these reductions are okay. And he was saying that that it can be possible to somehow not execute all the reductions, again, to be sure that the whole thing is valid. Which is very similar to what zksnark is talking about, right? This is like you want to prove continuity of your execution. And I was thinking that is this related to what Greg was talking about, execution places and how to, So I'm thinking that if you have if you have some kind of crypto way to prove your execution, maybe this is like an easier way, and you can always do that. But maybe there is a much more lightweight solution to do something like that. So I'm not sure if this makes sense, but
It sounds like, I don't know if you checked out any of those links to like the Coda project that I had dropped for a second. It's reminding me of that.
Yeah, I was looking at some of these links. I'm not sure.
Yeah. Oh yeah. There's just a million links that are flying around everywhere, right? But yeah, but the idea was basically like you can, so like so verifying a blockchain takes a long time, right? It's O of n, and n is the number of blocks. And that, you know, no matter how small you make each verification computation, the time complexity is still linear. And so the Coda project was trying to solve that by saying like, okay, well, we can imagine this scenario where we like, instead of replaying all the transactions to get from block 0 to block 1 and 1 to 2, we just do a zksnark for each one. And like, great, that helped. But again, it's still linear. So then their next idea was, we do a zksnark to show that you can get from 0 to 1, block 0 or state 0 to state 1. And then we do a zksnark, not from state 1 to 2, but the next zksnark says, there was a correctly verifiable zksnark from 0 to 1, and then I did this data to get to state 2. And so for each block in the chain, it's still just like a single snark over all the previous ones and the couple new transactions.
Mm.
But what this means, you know, from perspective of computation, you somehow want to encode semantics of your language, right? Somehow.
In the snark, you mean?
Sorry?
In the snark?
I mean, I was thinking that is this like a more fundamental, you know, because you want to be sure that all these transitions are valid, right?
Yeah.
Like this difference in previous state and this new state, and this difference between these two states is valid reduction in my language, right? In my higher language on top. Yeah. So I'm thinking that this is like semantics of your language.
Yeah.
You are encoding semantics somehow. And I'm thinking that you can always make some crypto on this difference and, you know, encode this, save and say, okay, I have it. Or you can take Genesis hash and encode it in each successor, right? And you can always say, I'm invalid transition from the Genesis. So you can easily check with each block. You can easily check, oh, I'm from this Genesis and everything is fine. Okay.
Yeah. Yeah. So, okay. So you're thinking back to Genesis, right? Like identify by a Genesis block. So let me ask this question. Here, let me try to get at why I don't think Genesis block is the right way to do it anymore. I mean, as you know, we talked for a long time about why I do think that's the right way to do it.
I don't mean Genesis in a sense, the first block.
Oh, yeah. Right.
I mean,
the state that you care about.
Yeah. You can say for each 1,000 blocks, I will take I will take this one, and you know for each 1,000 that is passed, I will use this hash, right?
Yeah. So like you're saying like checkpointing your way through history?
Yeah. This is like a checkpoint.
Yeah.
But for me, this is like a primitive solution, right?
Yeah. So we all have the privilege of having been born before blockchain started, but you know, if you think to a future time, well, you know, we're in that future time literally right now for young people, but even like 100 years from now, there'll be people who are born and raised and have to answer the question for themselves, like, which tokens do I think are the real ones or the ones that I care about, right? Like, which am I Ethereum or Ethereum Classic? Am I Bitcoin Cash or Satoshi's Vision or whatever? And so I think like, to some extent, the real question that we're trying to answer there is not one about like, from where did like this all begin, but more of like, you know, here I am finding myself in this world, and like I just need to choose which of these consensus forming cartels or whatever is the real one or the real ones. that I care about.
Just based on like current states of affairs, like value and things like that.
Yeah, well, right. That's kind of what I'm wondering. Like, I don't know if there's an objective way to do it. That's kind of why I'm like pushing this idea of consensus metagame, because I feel like it really makes explicit the fact that the fundamental question we're answering here is like, which common history am I subscribing to? Like, which view of reality am I participating in?
And you can use these checkpoints from other networks as a starting point for your network, right? I mean, you can save this like Genesis on the Bitcoin network, and you can say like this is like all network you can trust the whole network. It will live forever, and
yeah.
And you can say, okay, I will store my Genesis cache on this network. So, and you do this for like a multiple networks, and you say, okay, these are my starting point, right? Because we were talking about something like that. You can have multiple parents, and you can just made up the cache, but this cache, but you can also say, okay, this cache is on the real network. You can check it.
Yeah.
Although you don't have like a real control of this network, so somehow this network can disappear, right?
Yeah.
Yeah, as far as the Genesis block being just like another state transition, if you try to see it like that, the other thing that you get from the Genesis block is just the knowledge that there isn't necessarily a state before it, and therefore you know that everything from here you'll have the entire state of the blockchain. Versus a later transaction, if you try to just start from some delta, then that delta might not have all the information in the entire network, right? Because it's just going to omit anything that didn't change. So
yeah, so Jay, you're saying like one thing that does make a Genesis block special, even if it is itself more of a transition than a state, is the fact that it self like testifies or whatever that it is coming from like whatever the Genesis state was, I'm coming from it.
Yeah, like if you say there's some algorithm that starting from this block you move down the chain towards the tip and build state over time, the Genesis would be defined as the only block where you get the entire state of the machine. Actually, I don't know if that's true. Damn.
Are you thinking of because like concurrency or?
Just based on the fact that each delta is only going to tell you the changes that happened and not the entire state. So if you start from Genesis and then follow all the deltas, then you'll see everything that has changed. And if you start from some delta in the future, you might not see everything that's changed and therefore might not have the entire state.
Yeah.
But it is possible that there is some other later block and down the chain that from there all state has been covered, so you still would be able to see or get a full picture of the state.
Yeah.
I was thinking along these lines that one way of looking at it that seems interesting to me is if you say that the Genesis block is the only block that is its own proof, and in saying that it takes on sort of a identity element nature. I don't know if that resonates in any way.
So you're thinking like sort of just like identifying the Genesis block as well, basically just like reaching social consensus that this is the starting point?
Or do you mean identity like the identity property in an algebra or something?
Yeah, that's kind of where I was going with that. Thinking that there might be a way to look at this mathematically, that or algebraically that suggests a better model for. I'm not really sure, Joshi. What are you looking at? Is it a better model for talking about consensus? And,
yeah, with consensus metagames, you mean?
Yeah.
Yeah, that's right. I'm basically trying to like promote this framework of thinking about what it means to have consensus on something, and like, you know, then within that framework, what kind of like interesting things can we do, like forks and merges and sharding and all of that stuff. Yeah.
You know, the other thing is,
but I'm sorry, Jay, but in this idea of initial block,
Yeah.
you know, what are you looking for when you talk about it being just another transition? I mean, when you look at it that way, what are you trying to do for yourself?
Oh yeah, like why am I making this big fuss about saying like there's nothing special about the Genesis block?
Right.
Yeah, well, okay. So I guess one thing I'm trying to eliminate is coming back to this sense. So like imagine you have some DAG, right? Some concurrent version of a blockchain where like blocks can have multiple parents and stuff. If we insist on a Genesis block, then at least at Genesis, we're saying like we have to come back to this single point where the DAG is no longer like wide. It's just a single block. And then I'm saying like, okay, that kind of makes sense. We all want to start from the same point, but since blocks aren't, so like, okay, imagine let's think about this. I've been thinking a lot about like file system backups, right? Like I've got this folder on my hard drive of all these photos that I've taken over the last several years, and I don't want to lose those, so I do these file system backups. And so there's a couple ways you can do it. One way is that like every so often, let's say once a month or whatever, I get a new disk and I just copy all the files to the disk. Next month comes, new disk, new copy, third month, new disk, new third copy. And so at that point, I basically have like snapshots of what the state of my photos directory looked like. But another different way to do it is what's called an incremental backup. And in that scenario, only the very first time do I make a full copy of the data. And then after that, I just record deltas. I say what's changed, right? I added this photo, I deleted this photo, I added these new ones.
Mm-hmm.
And so the blockchain way is that second way where everything's incremental, where the blocks say, here's what's changed since the previous block. And at least in Bitcoin and Ethereum and all the popular networks, even the Genesis block is like that. Even the Genesis block is just deltas. It's saying, here's what's changed since some implicit starting state, which like in Bitcoin is there were no tokens. And so the Genesis block is just mining the first like block reward.
Exactly, because it doesn't have like all possible public keys set at 0.
Yeah, exactly. So I guess what I'm saying is like the Genesis block is not that initial snapshot where I took a copy and then all the other blocks are deltas. Even the so-called Genesis block is a delta. And like in the current scenario with blockchains, that starting state is always left implicit.
And the reason that we would want that in a consensus metagame is it means that you don't have to zip up two networks back to their Genesis.
Okay.
Yeah.
Yeah, that helps.
You can start at some later point.
Yeah.
Yeah. But yeah, that's the issue, is that you still just need some concept of knowing that you have the entire state of the network as it is right now.
Yeah.
But you can store, right? You can store the exact data in some moment. You can say, okay, in this block, I will store exactly balance for this account.
Yeah.
And you will have consensus, and this information is correct, and you don't have to check back to the Genesis, right?
Yeah.
That's like only for one account, maybe.
So Tomislav, you're saying like maybe let's stay lightweight and make most of the blocks just deltas. There's lots of good reasons to do that, mostly saving disk space. And then every once in a while, just to solve this very problem, we actually do the heavier weight thing and put on like a full snapshot.
Yeah, and maybe you can do this off chain. right? You can say, I will store the hash of something that will give you this information. And when this someone else give you exactly this information, you can check if it signed with this signature or something. I don't know.
Yeah. So
That
actually,
sounds like another consensus metagame.
Yeah, definitely.
so now that you're saying that, I think a lot of blockchains do that actually. Like I know in Substrate node, there's always what they call the state root hash. So the state itself is not in there, but the hash of the state is in there. And so when a validator or miner or whatever gets a new block and re-executes the transaction and ends up with a new state, they can make sure they did it the same as everyone else by hashing their state and comparing it to the state hash that came through on that block.
And where is the state stored?
Well, in Substrate, like you mean like just in a regular running operating network?
I mean, you said that you're storing hash to check if this is okay, but you must somehow store the state, the real state, right?
Yeah,
Each
each node stores the state locally on disk or in memory or however they like, but it's not part of the blocks that we're gaining consensus over.
So you don't, if you, so inside the blockchain you don't have the state. You only have a hash.
You have a hash at every block of, well, and so again, remember there we're talking about an actual chain too. So you have a hash of like every snapshot. Yeah. Oh, so yeah, it's almost like a checksum of the full state actually.
Yeah. I'm just thinking that
you just compare that with like neighbors. Like how do you like know that who you're comparing it with is?
So yeah, so the way it goes, so like let's just assume we've been playing some game and so far somehow we've stayed in general consensus. And then so let's say like I make the next block here and my block is going to contain a couple of transactions. It's going to contain a parent pointer and it's going to contain a signature and all that, whatever it has to go in there. And it's not going to contain a full copy of the state. And so I package it up and I ship it around to you guys, the other validators in the network. And so you look at it, you make sure you have its parent block and everything. And then you go through and you re-execute each one of those transactions. So you as a validator also have your local copy of the state. And so you replay each of these transactions from my block on top of your state. And when you're done with it, you hash your own state that you got yourself. And you say, okay, I got this hash. Let me now compare my hash to this hash from the block that Joshi sent me and see if they're the same hash. And if they are, then you know that you did it the same way I did it.
Interesting. And I'm assuming you only hash things that have reached finality.
Oh, wow. No, I actually don't think that's true. So you're hashing like the entire state after the block. And then so like basically you're hashing the state that the network will be in should this block ever gain finality. And then, so then, later, well, like in Substrate later, the pre-votes and pre-commits come in.
Okay, I see. So you're not, you would take a block by where it is. Mm-hmm. And like, so at a later point, if that block reaches finality, you can check that your state matches. Makes sense.
Yeah. And then, and like, let's say for whatever reason, maybe me and Tomislav produce blocks around the same time and you, like, Jay, you get it and you do the process we just described in mine, and then you get Tomislav's, then you have to like actually roll back my block to reapply his changes so that you're applying them to the same place that he applied them.
Yeah, that's really cool. Yeah. I like that.
And then this is very similar to RSpace, right? They're storing the same thing, but the state is inside the block, not only hash.
Yeah.
But I'm thinking, what is the difference? You're sending hash, but without the state, you don't have, you cannot check. So if I'm sending you hash, I must send you the whole block, the state also.
Well, no. The idea is that you don't have to send me the whole state. I'm maintaining my own copy of the state.
Yeah, but someone need to send to you state the first time.
Yeah, totally. Yes, that's right.
Yeah.
Okay, in that sense, yeah, it's maybe better to have this separated, because someone else can just send you the hash, not the whole state.
Yeah.
But
Yeah, like
I think
it would actually make sense to put like these checkpointed copies of the state somewhere like IPFS or something.
Yeah.
Mm-hmm.
But,
Yeah.
but is this the same as how Arnold is now? Casper is now working on Arnold.
Not really.
They're not sending. I mean, they're not sending the whole block right every time. You first send the hash of the blocks, not the whole block.
My understanding of our chain is a little bit out of date. I know for a long time they actually did have the whole state in every block, but I don't think it was ever their intention to keep it like that was just convenient for debugging and stuff. And I heard Chris say recently that they don't do that anymore, which is, probably good.
Oh, I see.
Yeah.
But this is not the problem. I mean, this is the problem only for exchanging information, right? If you store it locally, I mean, there is no difference, right? You can store it in one block or however.
Yeah.
Right. It's only important to not to save bandwidth.
Yeah. Well, yeah. To save bandwidth and to save disk, because for the most part, the state doesn't change that much from block to block. Like you're just going to have a bunch of copies of the same stuff.
Mm-hmm.
I mean, I'm not saying it's impossible for it to change a lot from block to block.
Yeah. This is interesting.
Yeah, I just found out that the Rust compiler does iterative compiling, which I had never heard of before. But it's basically they take each node in the abstract syntax tree, and they leave that as compiled as its own little bitcode, LLVM bitcode file. And so when you recompile something, it might see, you only modified this one function. And so it'll go find the node that represents the abstract syntax tree of that function and only recompile everything down from there.
That is cool.
Yeah.
And the similar thing to this is how modern bundler are working now. They're working on the AST level, not on syntax level anymore.
Modern what? I didn't hear that.
Bundlers.
Bundlers?
File bundlers, or when like a webpack or parcel or something like that. They're traversing AST of JavaScript, and they can see what part of the AST you're not using, and they package only the functions that are really used.
So this is kind of, forgive my ignorance, Webpack is one of those tools for when I have like a shitload of JavaScript and I don't want my user to have to download each JavaScript file individually, so it throws everything I'm using into one giant JavaScript file.
Yeah, it bundles up in one file.
Yeah.
Also useful if you have a project that's all over your file system, in a whole bunch of different folders.
Yeah.
Like all of mine are.
And I was reading about Smalltalk. They can recompile a part of the program in runtime, right, and exchange the bytecode. So you can change only one function in runtime and exchange the code and run again.
Did you say at runtime, like self-modifying code?
Yeah. I was reading about reflection.
Oh, cool.
But you can do this in C#. I was using this in C# when I was generating the code, and then I wanted to generate code in the runtime, execute, and then discard. And in C#, you have some limitations of how can you do this, but they have app domains for each code execution, so you can load another DLL, but you cannot unload it. So you must use another app domain and then load the DLL, then you can close it.
Yeah.
You can do something like that.
Yeah. Cool.
Okay, we look like we're at a stopping point. I think if we're going to continue, which looks like we might, I will stop the recording now.